Hi class. Now we're going to talk about virtual function. So we already start to introduce the most basic example for virtual function. So today I'm going to go a little bit slower to go step by step about what is a virtual function and how it can be used in scenario like shadow object in our homework assignment number 3. So just to let you know, we have been working on chapter 13 and 14, inheritance and polymorphism. And since last time, we also talked about the shadow object, homework assignment number 3. And also, we are going to move into, probably not this lecture, but another lecture from next lecture. We're going to talk about pointers and references. And then the reason we're going to talk about pointer and references is because it is an important topic and it's really confusing for not just for people who don't know C well, even people who took EC at 36A in C, they still have some issue when they move the concept of references to C++. And also in C++, there is a very important topic called smart pointer. And we're going to go over that. And once we talk about pointer references, especially something we call the pointer to functions, then we'll actually go back to see how the idea of virtual function can be really implemented. Okay? So we talk about inheritance. Inheritance, basically, you have a base class. And it implements a concept called is-a relationship. So a derived class is a base class. So that's the relationship between those two. And then we can have a member function for each of the class. And maybe you have member function the same name. Like in this case, I have a member function foo in the base class. I also have a member function foo in the derived class as well. And I could specify the virtual function. If I want that function to be specified, then I can just add a keyword virtual when you declare your class in front of the function prototype. And that will help you to specify that a particular member function is a virtual function. But what we really want to study right now is saying that, well, what's the difference? The important thing is, what is the difference when you have that virtual keyword, which make that function foo become virtual function, versus that you don't have that, which you have just a regular member function. And what is the difference? And I want everybody to be crystal clear about that difference. Then you can apply the concept appropriately. So first, let's look at the example of a regular function. So assuming you have a regular member function, the function prototype is void, foo void. Okay, that's the most simplest one, right? And assuming you have foo both defined in the base class, now I call it my base. And you also have that function defined in the derived class. Now I call it my derive. Okay. So now we have a piece of code I want to show you. And assuming I create object 1 using the class definition of my base. And I create object 2 using the class definition of my derive. So now you have object 1, object 2 got created at some point of your program. And later you're going to call the member function foo. So I have 3 lines here. You can actually take a look on the slide. The first line is object1.foo, which is supposed to be. And object2.foo, that's the way it is. But the third line is a little bit interesting. What I did is I take the object2 but I casting with a reference to its base class, to the parent class. So I did my base reference casting in front of object 2, and then I call the member function foo. I mean, we're still looking at regular member function. So the question for us to answer right now is that, well, exactly, because in this slide, I have two different foo. One is associated with my base, one associated with my derive. And the question is, now I have 3 call to the foo. Call by object 1, call by object 2, and then call by a casting to my base of object 2. So I call foo, and which foo will be called? Is the base one or is the derived one? Okay, this one might not be too hard, but I still want to just double check, make sure you're clear about this. So for the first one, object.foo, it will go to the base, okay? Because the object is my base, so when you call foo, it will go to the base. The second one will go to the derive, because the object is derive. And derive has a method to support that foo, so therefore it will call the version that's associated with my derive. Okay, the most interesting thing is the third one. The third one is object 2. The difference between the second line and the third line, it represents the power of casting in C or C++, is that when I actually name the object differently, I casting with a different object type. When I call the function, guess what? It will call the whatever is being referenced to. So at the time when I call this object, when I call this function, what is the type of the object? That will be the function I need to associate with. So in fact, casting allow me to control which version I like to call. So even though I am a member of class my derive, but I want to really call my base, casting is a way for you to do it. Okay, so this is the non-virtual function. This is what you're going to get. Okay, so now let's take a look at what happened in the virtual function. Exactly the same scenario. The only difference is that adding this virtual keyword in the class definition for both class my base and class my derive. So it means that you have to both of them set it's a virtual function in their member function declaration. Okay, so still I have exactly the same piece of code. Okay, 2 objects created. One is my base, one is my derive, and then I call the foo function exactly the same way. The first one is just object 1, the second one object 2, the third one I casting with using the type reference to my base class. Okay, so you might guess that now the behavior is different. For the first two, they're still identical. Object 1 go to the base, object 2 go to the right, but the third one is interesting. The third one, what we're showing here is that the casting does not provide any impact to which function you're calling. So essentially what we're looking at here is that it's not about the reference type of the object at the time I'm doing this method invocation, but it has to do with the time when this object was created, what's the type is associated. So the timing we're looking at is when it was created. What was the type we're dealing with? Okay. So that's the important principle about virtual function. I mean, the idea is simple, but sometimes you need to really write a few simple programs, and for you to get used to it, it's just the simple rule I just want to repeat again. The reference class type of the object at the time of the call. Sorry, I took it back. This one is a regular non-virtual function. So for non-virtual function, the reference class type of the object at the time of the call will determine which foo function you're going to invoke. And for virtual function is the reference class type of the object at the time of creation will determine which foo you're going to invoke. Right? So this is interesting, is convenient, is that maybe I create a object in one of my derived class embedded in this big class hierarchy. And the thing is that I casting it to a base class, so I can actually organize, because now I have object, say flight, object purchase, object meal purchase. I all consolidate into something called class transaction. So they are being created differently, but they all get into a base class which share some commonality. And the thing is that regardless how I consolidate, casting, change their reference type at the time of call, their original identity, original class associated at the time of creation is still there. If I want that behavior to show out when I make a function call, then I say this is a virtual function. And that's the basis for how C++ to implement one form of polymorphism. Okay, so this is my quick introduction about what is a virtual function, that hopefully this slides give you all the things you need to do. Remember, you have an inheritance relationship. Remember, you have to declare whether it's a virtual or not virtual. And then you just decide when you make a call, whether you want the function to be invoked is at the time of the call or at the time of creation. That's the only difference. Once you have these two, you should be able to understand virtual function. Okay, I hope you now have a clearer idea about what virtual function is. You really need to work some sample program to get yourself sharpening your understanding there. Okay, so now I'm going to apply the concept you just learned to homework assignment number 3. So I already showed you this last time when I did the demo for homework assignment number 3, that now I have the base class as a flight, and I have the derived class as a shadow flight. And I declare a member function called getDistance. And this is being declared in transaction.h or transaction.cpp. And similarly, I define a virtual member function called getDistance. And this is defined in shadow_fly.h/cpp. All right, so now I have this piece of code. With this, now we're trying to say, well, which one it will execute. So you can see that I also have a 3 object created here. The first one is a flight, F1, which is I created using flight. And the second and third is both what I call a shadow flight. It's a subclass from the flight, as you remember. And the same question we have, because this is a virtual function, then we need to decide the following. Is that assuming at some point of your code, you have some kind of object, I call it some F object, which has a reference type right now as a flight. By the way, when I say have a reference type right now, doesn't mean it was created exactly at this type. It's just when I saw it, it's a reference, is a flight. Okay, so now the question is that, okay, now I'm calling some F object dot get distance. Okay, so when I call this function, then which get distance will be invoked? Is that associated with a fly or associated with shadow fly? It depends, right? If this is f1, if some f object is f1, then the fly version of get distance will be invoked. But if it's f2 or f3, then the shadow fly version will be invoked. But regardless which version to be invoked, there's one very important point I try to emphasize from the programming perspective, is that when you write the program, you don't actually have to know whether it's a shadow fly or it's a fly. You just call the object and you expect the correct implementation of the virtual function will take care of the rest of the mechanism. In some sense, you don't even know where the fly object is, but you will just call it as it is here as a local, and then you will actually get it done. So for example, if you only look at these two lines of code that mark in red, the fly reference some f object and the some f object get distance. So in fact, when you only look at those two lines of code, you don't know which member function will get called. And you don't even know where the object really is. But you can include this in your code and develop your software, and then the rest of the stuff will be taken care of by virtual function and shadow object, as you will see in homework assignment number 3. So I'm actually making the code a little bit more concrete to show you that you can actually write this piece of code in this way. So I'm writing 3 blocks of code that is one line of the code is constructing the object, the other line is just to use this object. Okay, so you can see that the first block is very typical. I create flight object called f1, and I put in all the parameter. So this is somewhere in your code you actually create this f1. Okay, and then the second line, basically I say, okay, once I have that, I call this function f1.getDistance. I mean, you don't have to do that immediately after you create it. At some point, you do that, and then you're going to get the fly version of distance, getDistance got called, okay? And the second line, I'm actually really creating a shadow fly. And the shadow fly, the idea of a shadow fly is that it's really a proxy for a real fly remotely. So those 4 parameters that's being specified for the core object is help the RPC stack of software to locate the object. But as a programmer, you just basically give that information, and the system will use that information to find out when they need to access the getDistance virtual function. Okay, so that's, but if you look at the second example, the second line of the second example, if you take a look at that line, if I didn't tell you the previous line, you might not know whether that f2 is a shadow or it's a real object. All you know is you just call a getDistance, and the system will figure out a way to do that. Okay. The third example is similar to the second example, but I just want to illustrate the power of virtual function here. In this example, f3 is a shadow object. In this example, I casting fly reference before f3, before I call distance. And now, by now, you should know that when you make this call, you're going to call the shadow fly version of the getDistance to get it to work. Okay. So hopefully this example gets you to see how you can utilize this concept called virtual function in construct homework assignment number 3. So this picture is showing the part 2 of homework assignment number 3, the first requirement try to do just get distance. And as I mentioned, I have two virtual functions. One associated with fly, one associated with shadow fly, and their behavior are different. And therefore, when I want to access to the get distance, as long as I create the object correctly, I create the object as a shadow fly or fly, then the rest of the system, when I actually make the get distance call, it will either, if it's a real object, it will access the things locally. If it's remote, it will get access remotely. Just like the general concept of shadow object. You run your HW3 client, and it's a shadow. When you do get distance, it got related to the server, and the server has a real object. In fact, the server just connect to an object instance that match that object ID and class ID on that URL. And it will call get distance, but on the other hand, that call get distance might or might not be a real object as well. As I mentioned, that this concept could be have a multiple interaction. So you could have a a shadow connect to another shadow and then connect to another shadow. That's certainly possible. But that's the general idea. You can utilize this virtual function defining two different virtual member function, and then to show the difference between the real one and the one that's just represent a digital twin, which is the shadow of the real object. Okay, so so this is what we already implement is the fly object, and you probably already have the code, and you should try to run it and make sure you understand this picture. And then when you define a F object, which is fly reference, and then you call that get distance, and this code should run regardless where you are, regardless where you put your real object, that this piece of code is mobile. It can be run on anywhere, and then it will direct you to the right place to get the information as if everything is local. Okay, that's the fly object. Okay, so I'm actually going to talk a little bit, give you some more information about step 2 and step 3 when we look at the operator equal on the class person, and as well as conflict of interest in class flight. I want to tell you that it's an extension of the concept that we just introduced about get distance. On the other hand, these two steps does require some extension about the concept that you already heard from me last time. So I want to go over this a little bit. So here's our hierarchy that we have core, transaction fly, and shadow fly. Okay, that's on one side. So for implement the operator overloading, I'm going to have a shadow person. In fact, I think you must have a shadow person class in order to do this correctly. Okay, so now you can see that I have virtual Boolean operator equal on both person class and on shadow person class as well. So similar to what we have with get distance, that the version of operator equal in the class person is going to really compare to VSID. But the version in the shadow person is going to relay that request to a remote location where the person object really being hosted. Okay, so now let's see what happened in the object space. So now I'm drawing a picture. So this is still shadow object. Now it's a shadow person object instead of shadow fly object. And then you're going to call operator equal to the real server, which is a person object, and you're going to invoke this command called person : operator equal, as I show you on the left lower corner of the code. Okay, so inside this code, it take one parameter, which is a person, which is also a reference to a person, and it will return the comparison result between the VSID of this object and the VSID of the a person. Okay, so that's the function I want to call. I want to call it locally, even though I know the person, or maybe one or both of them, are actually not in my local, but I'm going to use the virtual function and how I define shadow person to actually implement this. And some of you might already realize this is something new, because what you're doing here, you are passing a reference of an object to a remote location. Okay, that's interesting, because usually when we reference an object, we're thinking this object is local, it's actually in the memory. But now what do we mean by reference an object that's a person is actually in the remote place? So for example, if I shift this to a remote place, it could be a person, the object is not there. And it could be it's in another place, and the thing is that how do we actually handle this situation? So that makes things a little bit more complicated, and that's the challenge I want you to experience, because if you can handle this, you can handle pretty much all the scenario that's going to involve object. Okay? So the thing is that we have to decide two things. The first thing is, well, how do we pass the a person as an argument remotely? How do we actually pass that reference remotely? And also we need to decide also later where it is. So we're going to solve the first problem. The first problem is probably easier. The first problem is that when I pass a reference to a particular object, what I can do is using the core object we already defined. By the way, core object, that's why core object has a 4 parameter, which is host URL, owner VSID, and class ID, and object ID. So when you want to compare two objects, that the a person as an object, that object should have these 4 elements as well. Where it is, what's the owner VSID, what is class ID, and what is object ID. So I will pass those 4 to the remote, and such that the receiver will actually get it. Okay, so that's number 1 that I will have, right? Okay. So okay, I know how to pass the argument to the remote. And now I need to do the next step. Of course, I pass to the object, and the object, now I take a look at the operator equal implementation for the real object that associated with the class person. You can see that the first one, it will return this VSID. And this part is okay, because you already route that whole call to the object, the real object, not a person, but the real object of that call, who received that call. And that object, of course, it should have this VSID. Well, however, if you look at the code, the next thing I need in the equal is that I need to look for a person's get VSID. And that get VSID is a virtual function as well. Because why? Because if a person is also locally the same host with this particular object, when you do comparison, you can directly call get VSID on the a person. But what happens if that a person is somewhere else? Then essentially you need a secondary redirection. You need to relay the second part of this statement to a remote location and get back the VSID. And then you do the comparison, and then you send back to the original Homework 3 client. So that's actually now involved 3 sites potentially. So now let's look at what's happening in the class hierarchy. So essentially, in order to do homework assignment number 3, part 2, step 2, that you will have this class hierarchy. You'll have a person and shadow person, but also you will have 2 different virtual functions. The first one is operator equal to equal, operator equal equal, as I showed you earlier. The second one is actually you need to have a virtual function for get VSID. So with both being virtual, then you will be able to handle that particular operator overloading equal equal, even the object are in totally different places, okay? And also similarly, you need to do that with JSON. When I say you have 2 different virtual functions, that means you need to have 2 different entry in the JSON file to facilitate both this situation, okay? All right, so this is the scenario now we're talking about. Now you can see that I redraw that you have a shadow person, and then it will go to the person who is a real object, but the argument to that call operator equal equal itself is a shadow person. And that shadow person will access to the real object somewhere else. And then you will be able to, when you pass the first operator equal equal to from the first shadow to the person, and then from the person to another person is actually a virtual function of get VSID. Okay, so with this 2 stage, then you basically implement truly implement the correct version of operator equal equal. Okay, so this is what I want you to develop a system that you can allow the object to be in different places, and you can still get the operator overload to work for the class equal. And regardless what you did, that think about this piece of code I show you here, that this piece of code doesn't need changes. You see that I'm actually having this piece of code when I have everything local, something on the server, something local, or even separate in 3 different places, that this piece of code I define associated with person are going to be the same. And the rest of the code is just facilitating how this is going to work. Okay? Okay, so now I'm going to talk about the step 3, which is how do you handle conflict of interest. I mean, if you understand how I just described to you how you can handle the operator equal equal, to handle conflict of interest is very similar, because it's just adding maybe another one virtual function, but you need to worry about the locality. Make sure you can process all the cases in terms of where the object is located. So let's look at the original code, which is already included in your tar, is the fly colon conflict of interest. So just let you know that you have a class called transaction. Under transaction, you have a one member, which is called transaction agent, and the type is person, reference to a person. And then class flight is a subclass of class transaction. And under the subclass fly, there is a one parameter, which is also a person, called FL passenger. So I have a 2 person in a fly object, but one is associated with transaction, one is associated with a fly agent and the passenger. So conflict of interest is just trying to detect whether the person who issued the ticket is the person who's going to use the ticket. So if you think about this is an airline, one of your favorite airline, that somebody actually sell the ticket as an employee of that airline to themselves. I mean, this might be legitimate, but just assuming this is something you like to detect, then you can actually use this piece of code to do that, whether this 2 person are the same person. Okay, so we have multiple things we are actually blended here. Number 1, we have this class flight, which we have a shadow flight because conflict of interest may be invoked in a flight that's actually hosting remote. And second, we actually involve two other objects, which is the agent and the passenger. They're both person object, and I don't know where they are. They could be on the same place. They could be one remote, one the same place, or both of them in totally different place. And the third thing, we have, if you pay attention to the implementation of a conflict of interest, it has that operator equal you just implement in step 2. So it's kind of blend almost everything: the fly, the person, the operator overloading together, and then plus the shadow object that you're bringing the whole things together. Okay, so that's the step 3 we need to worry about. So this is the way you have to think about how you're going to do this. Okay, so again, you have a shadow object called a remote object, which is in transaction. Is about conflict of interest. And then in that transaction, I have to know whether that TR agent is local or remote. So at that time, when you want to bring that in, you have to check. If it's remote, then you have to ship it and then send it over there. And of course, you have to decide, okay, sorry, I actually skipped one thing. And of course, you have to use, again, our mechanism to do operator overloading, and then you can take care of the overloading part. Okay, so you have a different object, person object, fly object, and then you have the function of both the conflict of interest, and then locate both person, and then you have the operator overloading. If you've done everything correctly, you will get this picture. So now this is essentially what I hope you have after you've done all step 1, 2, 3 for the part 2 of homework assignment number 3. That you can see that now I define the virtual function in the transaction and fly called, in fly and shadow fly called conflict of interest. That's doesn't take any parameter. But then I have on the person side and shadow person side, I'm utilizing step 2, what I already developed for operator equal, and also for the get VSID. You already done that. And then you change the JSON to support all such function. And then you build your server and the client code to bring some different scenario and testing whether you can really handle all the cases. Okay. Okay, that's what I want to cover today. So basically, I talk about 2 things. The first thing is talk about what is virtual function and how to use it, and what kind of difference it will make when you compare to a non-virtual member function versus a virtual function. The second part, I really show you that the idea is really powerful. If you want to do something like a shadow object, which allow you to do a lot of transparent distributed resource management, where when you program, you don't really care where they are, but you write the program once, and at the runtime, when you set the parameter correctly to store the object in different location, and your code utilizing the JSON RPC and shadow object and virtual function, and they will work perfectly nicely together. Okay, enjoy your coding. I will see you tomorrow.